I'm going to be talking much more about how to actually go about deploying this at a site. Dave talked a lot about the theory, the 10,000-foot view. There are a few places where our slides will touch and where I notice that that's actually happened. I'll try to go a little quicker because I don't want to let you fall asleep on material you've already heard. One point that Dave was talking about was what the standards require you to sign, what they recommend you sign, and so forth. And from the best of my memory, unfortunately, the wireless went dead while I was sitting there. I was going to look it up, but you are required to sign the from header field. Then there is a list of them you should sign, the theory being an attacker that can hijack your signing can alter a field that can cause a victim to do something. So if you change the subject header to something that would be more attractive as part of a DKIM attack, that's why you want to protect the subject header, for example. Or the date can affect where a message appears in your inbox summary. So fields like that are on the recommended list. And then there's a list that they say you shouldn't sign because they are very likely to be added, removed, or modified in transit that will invalidate a signature. An example is a received header field. If a message passes through a gateway that might redact or remove header fields that you've signed, such as received, that'll break a signature. So those are on the you shouldn't sign them list. But there are none that say you must not. That's my memory of the spec, actually. And Dave talked about statistics a little bit and how it would be really useful to have some. Let me get this into a useful spot. It would be really useful to have some. The software that I'm going to talk about today, it's the open source DKIM stuff that I work on, does have the capacity to collect statistics. What it collects and how it reports it is something I kind of invented thinking it might be useful. So if you deploy this stuff and you realize that there are stats that we could be collecting that would be of use to your operation or used to figuring out whether DKIM is useful in general, then by all means make that suggestion and we can make the change in the software. So I'm starting right away with a little bit of overlap. Dave was talking about flow of mail as a stream from your source, a fire hose pointed at you, but you also have a fire hose pointed outward. And when you're thinking about signing, think about whether you want all of your mail to appear as one big unified stream that will eventually have one big unified reputation, or if it would be useful for you to partition that separately. Dave likes to pick on marketing, and frankly I do too. If you have a stream of mail, let's say you're a bank, and you have a stream of transactional mail that is important to get to your customers, and it's important for them to believe that this mail has integrity, it came from where it claims to have come from, and its content is valid. And then your marketing people send out a blast of what everybody else thinks is spam, and so the reputation of your organization as a whole goes down. Your transactional stuff will suffer as well. So you might want to think about creating partitions in your namespace. So for example, you would have, I have an actual example of this later. Create a subdomain for your transactional stuff and a subdomain of your organization for marketing and however else. Now, when we get to the point where reputation is widely deployed, the expertise that I have and have spoken to others about suggests that we're going to be looking at the host and the domain, so the subdomain and the real domain. We're not going to develop reputations about specific users because those spammers can change those too quickly and pollute our databases with a whole lot of users that we only ever see once. So we're not going to be interested in that, and it's too hard to figure out just your domain name. So if you're, pardon me for using a real-world example, but bankofamerica.com, if we were to try to figure out that bankofamerica.com is the real domain here, not a subdomain, that's difficult to do without a lot of knowledge about the namespace because how do I know? I know that you know that you stop at com for com, but you know that you stop at co.uk, so there's two labels instead of one. You don't really know where to make that division in an automated sense. You have to keep a list of top-level domains someplace, and that becomes a hassle. You really want to get this automated. So we're going to be looking at the whole host and domain name pairing. And I talked a little bit about reputation here already, so the best practice is to make these divisions. I'm going to fly through some of these slides. You saw that I had many of them. They'll all be available to you for download, so if I go too quickly and you want me to cover something, go ahead and slow me down, but otherwise just download them and go over them at your leisure as well. So once you have subdomains chosen, now you need to think about keys within those subdomains. If you have security people on your staff, they're going to talk to you about how you should change your passwords regularly. Well, the same kind of thing can apply to the keys that you're using for signing. It's possible a key could become compromised and given out to a spammer who can now start signing as you, for example. Someone might manage to get one. It's unlikely they would be guessed. It would be more likely that someone would manage to steal a private key. So you might want to change them frequently. You might also want to, if you're sending a lot of mail campaigns, let's say you're an ESP, you might want to use a different key for every campaign you send. It really is a matter of local policy of how you go about doing this. What way you want to pick them. The common thing that I've seen for sites in general is to have one key per year. This is a common practice for when you have digital signatures to protect your software. They'll generate one master key and then generate an annual key. And so, keys would have expiration dates associated with them, which isn't really a thing with DKIM. But when you're doing key rotation, though, one thing to keep in mind is when you send a message with key X, it's signed and that's great. Now you're going to roll out key Y. What happens to things that are still signed with key X? You may need to leave both keys up in there, in your published key set for a little while, so that mail that took a while to get to its destination, or things that get reevaluated for some reason later on, would still be able to be validated. So you have to plan with your DNS people, for example, to say, I'm going to be putting a new key up. No, I don't want you to delete the old keys yet. This key might still be good for another 6 months or a year. So there's a lot of policy you need to talk to your IT people about when you're planning how you want to do your keys and your partitioning of your domains. Another thing to think about with signing is basically your internal infrastructure. So where you may have a site, if you haven't rolled out DKIM yet, you're sending mail. Basically, anybody who's got a Linux box can send mail out directly. You may need to stop that, because now you need to get all that mail signed. If you have a whole lot of Linux machines out there and everybody's got his or her own desktop, it can all send mail in or out through the gateway, without a gateway, all that mail now has to go through one or two or a fixed number of places that actually do the signing. Or you have to get all of those machines signing and manage all the keys. That's going to be a giant hassle. Well, for a lot of places, it would probably be a giant hassle. The bigger your company, the bigger a hassle it will be. So now, this could cause a change to your email infrastructure, in that you have to funnel things through the signing servers. Something to consider. If you're already doing that, where you have only 1 or 2 signing servers, you're probably in good shape, but there are a few places where that's an issue. Roaming users is another interesting question. If you have a laptop here, you're from out of town, and you want to send a piece of email that is signed by a key that your company has published, how is that going to happen? Do you have a copy of the key? Do you really want copies of the keys on roaming laptops for people who don't really think about security very much? That's probably not a very good idea. So you need to think about how people with roaming equipment are going to be able to get mail back through some kind of signing server or do their own signing. This is a big question for IT policy as well. The answer is almost always going to be you jump back in through a VPN and send it back out through an official company server. It really depends on what you can do, what your requirements are, but this is something that you need to plan in your infrastructure. And with all that theory aside, I'm going to actually start talking about how you would do this. Some of it's right down to the command line level. If you have any questions, or actually if you see any errors in my slides, go ahead and raise your hand, or just shut them out. So everything operates in key pairs. As Dave said, we're not going to get into the mathematics of how all that happens, but suffice to tell you, everything happens in pairs. The private keys you keep to yourself, the public keys you put out so that people can retrieve them to do verifications. You generate a pair of keys using a command. You can, that's part of an open source package called Openssl. You need a specific version for some DKIM things. The version number is here. This slide's actually probably in a slightly different, slightly out of order, but if you're talking about key delegation, if you work with a mass mailing company, ESPs, if you want them to sign mail on your behalf, you can give them a private key that they can use to sign your mail, and then you publish the public key. So they are now able to generate signatures on behalf of your domain that will validate. So what we recommend is that you generate the key and you give it to them. Don't give them a copy of a key you're already using. That way there's a good audit trail between the keys you've made and the keys you've given out, and you can actually invalidate theirs without invalidating all of your mail, for example. So back to this. Key generation is really very simple. You give the name of the file you want to stick the private key in, and how many bits of encryption you want to use. 1024 is kind of what everybody uses. The more you put into it, the more difficult it would be to guess the public key, the key information. The mathematics is very complicated, and the more bits you add, the more complicated the guessing of it would be on a geometric scale. However, you start to run into some issues with storing very large keys in the DNS. So try to find a good balance. If you, I think at about 4K, once you're using 4K, the DNS software starts to have to do some interesting things with the transport because it's not built to carry messages that big. It will still work, but a few DNS implementations actually get that transition wrong. So depends on what software limitations you may have. And then a second command here will generate, given a private key, will give you a public key. And these two files are all you need really to get set up. And a little discussion about what private and public keys are. Without getting into the math, you use the one key in any operation to encode something and the other key to decode it. The one you keep private is the stronger of the two. If you sign something with a private key, then anybody can get the public key. Once you've signed it, that means that anybody that can get the public key can verify that you're the one that signed it, because you're the only one that's got the private key. An interesting flip of that is anybody who signs something with the public key, you're the only one who can verify that it was signed with your public key, because you're the only one who's got the private key. So that's really it. That's yes. And what are signing and verifying? Well, the operation is one of encryption. Well, we don't want to encrypt the entire message, because encryption is actually a very expensive operation. So DKIM doesn't take your entire message, which could be, I've seen people email around ISOs and sign, which are 760 megs of data, and try to sign those. You don't want to encrypt that much information. It's extremely compute expensive. So all you do is compute a hash of it, which it distills any piece of information down into 40 bytes or some small number of bytes. The idea being, if you change even one bit someplace in the original, what you get out is completely different. So that's how we detect that there was a change made. The hash of the large amount of information comes down to this small thing, but it changes very dramatically if there's any slight adjustment above. So when you encrypt a hash, which is much cheaper than encrypting an entire message, that's a digital signature. And when you verify that the hash produced would be decrypted the same way in reverse, then we say that the signature is validated. So when we use those terms, that's exactly what we're talking about. And what you get out of these OpenSSL operations is a blob that looks something like that. It's just an encoding of these bunches of really large numbers, which are what's in a key. Now you have to put this someplace where remote agents, verifiers, when they get a piece of mail signed by you, can go off and say, well, what's the public key? Where can I get the public key? And like Dave said, we put this in the DNS, which I'll get into some of the politics of the use of DNS for that a little later on. But that's where they currently are. We discussed early on in the working groups, I can't remember whether it was domain keys or DKIM early on, but we were talking about doing some other key generation or key distribution, whether we maybe do it through web servers or some specific key management system. And we thought, well, we'll try DNS first and see if that works. And it turns out that's the only thing that we've rolled out. So we had all these great ideas for more complicated things, and why make it messy? And you need a few more things. Dave mentioned selectors. These are specific names of key pairs. So if you have the January signing keys versus the February signing keys, or the 2010 versus 2011, or marketing versus execs, those are names of pairs. And in the DKIM parlance, those are called selectors. You also might store some information along with the key. What kind of key is it? There's only one type currently supported. There's a flag in there where you can announce that although we have rolled out DKIM, we're not totally confident about it yet, so we're just testing it, which is a request of sorts to a verifier saying, please don't chuck our mail because it fails to verify. We're not certain that this is working quite right yet. So there is a way to have receivers detect that your confidence isn't quite there yet, so don't take any giant corrective action. There is a way to limit the use of a key to specific users, and there's a bunch of other stuff that I'm not going to get into because we haven't really even seen them used in the wild yet. So the answers to all of those questions, this is what they actually look like. What type of key is it? It's an RSA key. Am I testing? T equals, yes, I'm testing it right now. G equals would be which users are allowed to use these keys, star meaning everybody. And there's some little formatting sugar you can include in there to make it nice to edit or view in a program like dig or NSLOOKUP. Then you have to take this big blob back a few slides, all that, and crush it down so it'll fit inside a record. And there is some nice formatting you can do again in the editing, which I'll show you an example of. So you take this giant thing that comes out of OpenSSL as the public key, and you end up with this thing at the bottom. So you see I've taken, I wish I had a laser pointer, but if you take the K equals RSA, the T equals Y, and all that, that's just a piece of text, and you put all the rest of this stuff from the public key down in, and that's how you publish a public key. So this is what your DNS people, your IT people need to learn how to do quickly. There are some tools that I'll get into as well that show you how to do this for you. But that's basically the process of taking a public key from the shell and putting it up into a DNS record. So I'm going to start talking about a particular open source package called OpenDKIM that I work on in conjunction with some other people. It includes, among other things, this tool called OpenDKIM-GenKey. Oh, thank you. Which creates a pair for you and outputs two things, the private key and this DNS text record that I just showed you on the previous slide. So it does a lot of that massaging work for you. Your IT people will be grateful, especially if they don't actually know how to write a DNS text record. It doesn't do the line breaking. It's not as beautiful as it could be, but there are command line flags to adjust what it looks like and what comments might be there. So there are utilities to make this a little easier for you. Some other things, when you're actually putting your keys in the DNS, there's the idea of a TTL, or time to live. On every DNS record has one, but you've probably never even looked at it because they all use nice big defaults. When you are tinkering with keys, you may need to change them, either by name or what data are in them fairly rapidly. So you might want to set this TTL, or time to live value, low. This has two impacts. One is your changes. When you make a change to a name server, published record in a name server that has a low TTL, all the other name servers that see it will only remember it for a short period of time and then come back to you to ask, did this change? Is there an update? The bigger that number is, the more effective their caching is. So your name servers don't keep getting hit for the same question over and over again. But if you make a change, it also takes that long for the other servers to detect that there's been a change. So if your TTL is set for a day and you make a change, it can be up to a day before the new information is out there. So when you're rolling this out, you might consider using much lower TTLs, a minute, 5 minutes, 10 minutes. As you'll see a little later on, or actually Dave had in one of his slides, I think, keys live inside of what looks like a subdomain of your domain called _domain key. You can make this its own real subdomain by saying the name servers for _domain key are over there, which your IT people might find a great thing because now you don't have to go bug them every time you want to put a key in or take a key out or change a key. It really depends on, though, whether or not they're willing to cede control of something as important as security to your mail guys. There are some companies that have been clients of mine at past companies that were absolutely not interested in doing that kind of delegation. They would much rather take on the maintenance work themselves, even though they didn't quite get it. But there are others that would just rather make the mail guys go away, so they give them this little piece and say, here's your playground, go have fun. And so testing it, once you have generate a private key and a public key, we have this tool called OpenDKIM test key that will actually make sure the two line up, which suggests that if you sign a message with this private key, there's a public key in the DNS that will validate your message. So if this comes back quiet, then you've done it right. If it complains and wasn't able to get the record out, the data in the keys don't seem to line up. So Dave talked about author domain signing practices, which there's the RFC number for it if you want to go and read it, if you're like that. Like he said, there are 3 different policies that you can publish with ADSP. There's unknown, which essentially means I have no policy. My mail may or may not be signed. There's all, which claims we do sign everything. And as he said, there's a third one that says not only do we sign everything, but if you get something from me that's not signed, you are invited to throw it away. The specifics of ADSP actually say that, or actually of DKIM, say that a message whose signature failed to validate should be treated the same as a message that wasn't signed. So what ADSP in particular is saying is if you didn't get a signature from me that validated. So even if you signed it and it got to its destination, if you're announcing a policy like this, it'll be treated as if it were unsigned. So that means your DKIM equals all is now saying, this message from us is probably not legitimate. Now, maybe your setup is perfect, and when it left your gateway, it was signed and would have verified at that point. But if your mail went through a mailing list, for example, that tacked a footer on or changed something in the message, and now it doesn't validate, discard is going to cause your mail to get thrown away, or a site that takes all a little too seriously. You might have an issue there, and I think, yes. So the point that I was going to make is 2 slides away, so I'll come back to it. And you would put something like, if you want to take part in author domain signing practices, you would put this in your DNS as well. Underscore ADSP, underscore to distinguish it from another host name, and DKIM equals all, really quite simple. I like to categorize ADSP as it's essentially a software version of the agreement that was made very public in the media between Yahoo and eBay PayPal when eBay and PayPal told Yahoo, look, we sign everything. If you get something from us that wasn't signed by us, that didn't validate, just throw it away. And that was a big deal because it was the first step towards blocking that path for phishing, which had been very effective. So this is essentially a way for you to say to others the same thing that they said with contracts and lawyers and that kind of thing. Now you have to be careful, this is what I was getting at one slide back, you have to be careful with using these two because mail that you have treated perfectly up to your gateway can be invalidated on the way out through no fault of your own because of mailing lists or remailers that tinker with your message. And so you might cause some of your own mail to be thrown away or treated with huge skepticism just because you announced an all or a discardable policy. So just be aware that you don't really have, once it's out in the wild, your mail could be messed with in ways that you don't really want, and posting a policy like this could have detrimental effects.